Hello, family. It doesn't. Oh boy. I'm working on it, guys. I'm still working on my intro. Hello, statisticians works because that's three, what are they called? Syllables? Families only. Well, family's three. Family. Hello, statisticians. Hello, family. Oh, that'd work. That might be my new intro. Hello, family. Okay, so these are solutions for Can You Do 54. This one wasn't too long, so hopefully it was manageable for you. First problem is about songs on an iPod. So David's iPod has about 10,000 songs. The distribution of play times for these songs is heavily skewed right with a mean of 225 and a standard deviation of 60 seconds. So 225 seconds, how many minutes is that? 3.75 minutes. So they're saying that the average song length is 3.75 minutes. Suppose that we choose an SRS of 10 songs from this population and calculate the mean play time. What are the mean and standard deviation of the sampling distribution, and explain? Well, the mean will be equal to the true parameter because you took a random sample of 10 songs. So remember, your mean is the same as the true value if you took a random sample. I'm just trying to find our note sheets. So that's not the right page. This guy. Then our standard deviation is going to be found using this formula if the 10% condition is met. So I get that our standard deviation is 1.897 because the 10% condition is satisfied. That's supposed to say 10,000. N equals 10 is less than or equal to 1/10 of the population because 1/10 of the because the population is 10,000. So this is true. The 10% condition is satisfied. Explain why you cannot safely calculate the probability that the mean playtime X bar is more than 4 minutes, so 240 seconds, for an SRS of 10 songs. So we were able to find mu, we were able to find standard deviation, but we are not able to say that this distribution is normal because our sample size is not big enough. If your sample size is less than 30, your sampling distribution is the same shape as the population. We cannot safely calculate probabilities for a sample size of 10 because calculating the probabilities requires the sampling distribution to be normal. But the sampling distribution is heavily skewed right like the population. Central limit theorem requires that it has to be greater than or equal to 30. Well, suppose we take an SRS of 36 songs instead. Explain how the central limit theorem allows us to find the probability that the mean play time is 240 seconds and then calculate it. We don't need to explain. You can just skip that. Because all you would say is N is greater than or equal to 30, so the central limit theorem applies, which I wrote here. I should really have written the word applies. So, if N is greater than or equal to 30, the central limit theorem applies. So, for N equals 36, the central limit theorem applies. So, basically, I'm explaining how it works. You can see that they make it seem like you got to write a paragraph about the central limit theorem when really you don't. So now that our sample size is 36, our sample comes from a normal distribution because central limit theorem applies, 225 for a mean because SRS. What is this? Oh, and our, sorry, and our sigma is 10 because 36 is less than 1/10 of the population. Remember, the population is 10,000, so we're saying 36 is less than or equal to 1,000. Okay, this is the same as the probability. Sorry, this isn't the same. So we're finding the probability that X bar is greater than 240. Well, that's the same as finding the probability of Z being greater than 1.5. That is 1 minus the probability of Z less than or equal to 1.5, which ends up being 6.68%. So the probability that the mean play time is greater than 4 minutes is about 6.68%. So not very high. Plausible, but not very high. Number 2, dead batteries. If the brand new battery has the same lifetime distribution as the previous type of battery, describe the sampling distribution of the mean lifetime X. Well, this X will come from a sampling distribution that is normal because the population is normal. So here, N is equal to 8, but the population is normal. So we're Gucci. You don't have to say N is equal to 8. I'm only writing that down because you have to be careful when your sample size is less than or equal to 30. In this case, we have a normal sampling distribution because the population is normal. Mu is equal to the true value because an SRS was taken. Standard deviation can be calculated because 8 is probably less than 1/10 N. Well, what is N? All batteries. So 8 probably is less than or equal to 1/10 of all batteries. It's okay to assume that. That's reasonable. Okay, the average lifetime of our sample turns out to be 42.2 months. Find the probability that the sample mean is 42.2 months or less. If the lifetime distribution is unchanged, what conclusion would you draw? Well, probability of getting that sample value or less is the same as getting a Z value of -2 or less, which is about 2.28%. So the probability that the sample mean lifetime is 42.2 months or less is about 2.28%. This is convincing evidence that the lifetime distribution has changed. It is not plausible to get a sample mean of 42.2 months if the lifetime distribution is unchanged. So the probability we would get the sample that we got if it's unchanged is so low that that must mean something has changed. So I probably should have included if the lifetime distribution has not changed. So it's very unlikely we would get the sample that we got. Well, we got the sample, so that must mean something has changed with the mean lifetime. Insurance. What is the probability that the average loss from fire in the sample is no greater than 275? So they're asking us to find the probability that it's less than or equal to. So I'm just going to let you look at this problem. I'm not really going to walk you through it because I think it's self-explanatory. And then we head into the multiple choice. As you guys know, I made some errors in the multiple choice in the last can you do, so it's likely I made some errors in this can you do. So somebody will let me know and then I will correct it. For 4, I got beta. 5 is a question, like you can see here, that I think that this is a horrible question. The answer is E. You can just not even worry about this question. You do not have to worry about this question. 6. They want to know the sample mean is an unbiased estimator, which means that in all of our samples from this population, so in every sample we take, the mean of all of those samples will equal the true value. So I was making a note to myself that the mean of all of the values, the mean of the distribution of values, is equal to the true parameter. This is basically the definition of unbiased. So if your sample is unbiased, your sample mean, or your sampling mean, I should say, will equal the true parameter. And remember, a sampling distribution is all possible samples of the same size. 7, he's kind of tough. So what the central limit theorem actually says is that when n is large, the sampling distribution is approximately normal. So when n is large, your sampling distribution will be approximately normal. What we consider to be large is greater than or equal to 30. So as we look at more and more bulbs, their average burnout time gets ever closer to mean mu. No, that is, we're not saying when we take more and more people in our sample, no. The average burnout time of a large number of bulbs has a sampling distribution with the same shape as the population distribution. No. It only has the same shape as the population distribution when n is less than or equal to 30. Just kidding. When n is less than 30. Central limit theorem is telling you when it will be normal. The average burnout time of a large number of bulbs has a sampling distribution with a similar shape but not as, no. We're looking for the one that tells us it's going to be approximately normal. The average burnout time of a large number of bulbs that's like exactly what I wrote up here. And then lastly, just to verify, the average of a large number sampling distribution exactly? No. No, no, no. So, 5 is a horrible question. Everything else was doable. We'll bring some things together, hopefully, in our review next class period. We'll try to solidify as many ideas as possible. And then it will be test time. I can tell you for sure, and you have one of these in the review, that you have a problem like, oh, it's in the review. So I'll tell you when we get there. I'm going to try to give you a really good example of the free response you'll see in the exam. So make sure that you watch any videos associated with the review and you actually do and understand the review. Okay? Okay. Goodbye, family. See? This is so good. Love you guys.